Okay, this is Mr. Burns, and here's your video for lesson 1-AT, dividing by one-digit numbers. Being able to divide by one-digit numbers was introduced to you guys probably in elementary school. So I'm going to go through these problems rather quickly and explain to you guys what it is I'm doing and why I'm doing it. Look for patterns in the numbers and look for patterns in my speech. Therein lies the keys, okay, for dividing by one-digit numbers. Okay, for number 1, we've got 6 divided by 3. Now, if you want to set it up with a little house, you can do that as well. So the first number in a division problem is going to be your dividend. So dividend. The number that you are dividing by is called your divisor. The answer to a division problem is going to be the quotient. So that's the quotient. Oops, I better write this a little bit neater. And I better use a little bit narrower pen. So anyway, this is called the quotient. That's an answer to a division problem. Okay, so I'll use those 3 words to describe the situation. So you've got your dividend, the number that's being divided up, your divisor, that's the number that's doing the dividing, and then you've got your quotient, which is the answer to a division problem. So number 1, we've got 6 divided by 3. Or, in other words, what number, when I multiply it to 3, will get me 6, or as close to it as possible without going over? Well, that's the number 2. And then 2 times 3 is 6. When I subtract those, 6 minus 6 is 0. Now, is my remainder smaller than my divisor? If my remainder is smaller than my divisor, then I am done dividing. So my answer in this case is going to be 2, remainder 0, or just 2. All right, on to problem number 2. On problem number 2, we've got 8 divided by 2. So if I want to set this up with my little house, so I'm going to go 8 divided by 2. So 2 will divide into 8 how many times? Or what number times 2 will get me 8? That's the number 4. 4 times 2 is 8. Subtract those, I get a remainder of 0. So is my remainder smaller than my divisor? If my remainder is smaller than my divisor, then I know I'm done. So my answer is 4, remainder 0, or just 4. Number 3. 3, I've got 18 divided by 3. So how many times will 3 go into 18? Or what number, when I multiply to 3, will get me 18, or as close to 18 as possible without going over? That's the number 6. 6 times 3 is 18. Subtract those, I get 0. My remainder is smaller than my divisor, so I'm done. So my answer is 6, remainder 0. Number 4. On number 4, I've got 9 divided by 5. Or what number, when I multiply it to 5, will get me as close to 9 as possible without going over? That's the number 2. 2 times 5 is 10. Wait, 10 is bigger, or actually 10 is bigger than 9. So that doesn't work. It's too big. So I can't use 2. So let's try 1 less. So if I go 1, 1 times 5 is 5. Subtract that, so 9 minus 5, that's 4. My remainder is smaller than my divisor, so guess what? I'm done dividing. So my answer for number 4 is 1, remainder 4. Okay, number 5. Number 5, I've got 11 divided by 3, so I'm going to set it up with my house. So 11 divided by 3. 3 will go into 11 3 times. 3 times 3 is 9. Subtract those, I get 2. Is 2 smaller than 3, which is my divisor? Yes, it is. So guess what? I'm done dividing. So my answer is 3, remainder 2. Okay, on to number 6. So in here we got 15 divided by 6. How many times will 6 go into 15? Or what number, when I multiply it to 6, will get me as close to 15 as possible without going over? That's the number 2. 2 times 6 is 12. Subtract those. I get 15 minus 12. 15 minus 12 is 3. And 3 is smaller than my divisor, which is 6. So my final answer is 2, remainder 3. Okay, number 7, I've got 42 divided by 3. So in this one, we have to take them one place value at a time. When you're dividing, doing long division like this, you're going to start off with your biggest place value and work our way from left to right. So how many times will 3 go into 4? 3 will go into 4 one time. 1 times 3 is 3. Subtract those, I get 1. And then I'm going to bring down the 2. 3 will go into 12 4 times. 4 times 3 is 12. 12 minus 12 is 0. My remainder is smaller than my divisor, so I'm done. And my final answer is 14, remainder 0. Number 8, I've got 54 divided by 8. I'm sorry, 54 divided by 4, not 54 divided by 8. 54 divided by 4. So how many times will 4 go into 5? 4 will go into 5 one time. 1 times 4 is 4. Subtract those, I get 1. Bring down the 4. 4 will go into 14 3 times. 3 times 4 is 12. Subtract those, I get 2. 2 is smaller than 4, so I'm done. My final answer is 13, remainder 2. On number 9, we've got 86 divided by 8. So I've got 86 divided by 8. 8 will go into 8 one time. 1 times 8 is 8. Subtract those, I get 0. Am I done? Nope, I've got to bring down the 6. So 8 will go into 6 how many times? 8 won't go into 6. So I put a 0. 0 times 8 is 0. Subtract those, I get 6. 6 is smaller than 8, so I'm done. My final answer is 10, remainder 6. Okay, on number 10, we've got 113 divided by 5. So I've got 113 divided by 5. 5 will not go into 1, but 5 might go into 11. How many times will 5 go into 11? 5 will go into 11 2 times. 2 times 5 is 10. Subtract those, I get 1. Bring down the 3. 5 will go into 13 2 times. 2 times 5 is 10. Subtract those, I get a remainder of 3. And my remainder is smaller than my divisor, so I'm done. And my final answer is 22, remainder 3. Okay, on to number 11. Okay, on number 11, we've got James had 56 balloons. He gave the same number of balloons to each of his friends. So in part A, it says divide the number of balloons. So how many balloons did he have to start with? He had 56 balloons to start with. Okay, because it says James had. Whenever it says James had, you could rewrite this as an algebraic expression as James had 56 balloons. And then it says how many balloons did each friend get. So the second sentence says he gave the same amount to each. So whenever you see those words same and each, okay, that's going to signal that you're going to be doing division at some point in the story problem. So what you're going to do in this case for part A is divide the number of balloons he had, which is 56, by the number of friends. How many friends did he have? He had 5 friends. So we're going to take 56. Let me scoot that back over. So we're going to take 56 and we're going to divide that by the number of friends that he has, which is 5. This is how many balloons did each friend get. So I'm going to do the problem over here. So I got 56 divided by 5. 5 will go into 5 one time. 1 times 5 is 5. Subtract those, I get 0. Bring down the 6. 5 will go into 6 one time. 1 times 5 is 5. Subtract those, my remainder is 1. So how many balloons did each friend get? Each friend got 11 balloons. How many balloons were left over for part B? Well, he had 2. He had 1 balloon left over. Okay, so he has 1 balloon left over. Okay, number 12, it says Tawny had 93 tulips and 7 vases. She put the same number of tulips in each vase. So it starts out that Tawny had 93 tulips and 7 vases. She put, again, the same amount, okay, in each vase. So part A says how many tulips were in each vase, and then part B says how many tulips were left over. So just like before, just like the problem above, number 11, we're going to do the same thing. So how much does she start with? She starts with 93. How many vases does she have? She has 7 vases. So how many times will 7 go into 9? 7 will go into 9 one time. 1 times 7 is 7. Subtract those. I get 2. Bring down the 3. How many times will 7 go into 23? 7 will go into 23 3 times. 3 times 7 is 21. Subtract those. What's my remainder? 2. Now how do I know that I'm done? Well, whenever that remainder is smaller than the divisor, I'm done dividing. So my final answer is there are 13 tulips in each vase with the remainder of 2. Okay, backside. Okay, your instructions for the backside are going to be a little bit different than the front. It says find each quotient and then write any remainder as a fraction in simplest form. So here we go with number 13. So on number 13, we've got 73 divided by 6. How many times will 6 go into 7? 6 will go into 7 one time. 1 times 6 is 6. 7 minus 6 is 1. Bring down the 3. 6 will go into 13 2 times. 2 times 6, why, that's 12. Subtract those. So I got 13 minus 12. 13 minus 12 is 1. So here's how we rewrite this as a fraction in the simplest form. So my final answer is 12, remainder 1, over the divisor, which is 6. So our denominator is going to be the same number as our divisor before we reduce it. Now, since my numerator is already 1, I can't reduce this any farther. So my final answer is 12 and 1/6. So when the numerator is 1, you're done reducing. On to number 14. So number 14, we've got 92 divided by 8. 8 will go into 9 one time. 1 times 8 is 8. Subtract those. 9 minus 8, that's 1. Bring down the 2. 8 will go into 12 one time. 1 times 8 is 8. Subtract those. I have a remainder of 4. Now I am done reducing because my remainder is smaller than my divisor. So here's how we write this as a fraction in simplest form. So we've got 11, remainder 4, and then my denominator is 8. Now, can I reduce the fraction part of this mixed number? Yes, I can. What's the greatest common factor between 4 and 8? The greatest common factor between 4 and 8 is 4. So my final answer is this, 11. And how many times will 4 go into 4? 4 will go into 4 one time. And how many times will 4 go into 8? 4 will go into 8 2 times. So again, there's my final answer, 11 and 1/2. How do I know I'm done reducing? Because my numerator is 1. Okay, on to number 15. Okay, at number 15, we've got 82 divided by 5. How many times will 5 go into 8? 5 will go into 8 one time. 1 times 5 is 5. Subtract those. I get 3. 8 minus 5 is 3. Bring down the 2. How many times will 5 go into 32? Why, 5 will go into 32 6 times. 6 times 5 is 30. Subtract those. I get 2. And when I rewrite this as a fraction in the simplest form, I get 16 and 2 over 5. Now, can I reduce the whole number? No. So it's 16. What's the greatest common factor between 2 and 5? Why, the greatest common factor between 2 and 5 is 1. You got it. So when the greatest common factor is 1, you're done reducing. So my final answer is 16 and 2/5. Okay, on to number 16. 4 will go into 9 2 times. And I better move this over here, so I'm going to slide this over just a touch. So anyway, 2 times 4 is 8. Subtract those. I get 1. Bring down the 2. How many times will 4 go into 12? 4 will go into 12 3 times. 3 times 4 is 12. Subtract those, and my remainder is 0. So guess what? You got it. I'm done. Okay, 17 and 18. We'll move this up just a touch here. So I'm going to move it up and shrink this puppy down. Love this app. Okay, here we go, number 17. So 4 will go into 7 one time. 1 times 4 is 4. Subtract those, I get 3. Bring down the 4. 4 will go into 34 8 times. 8 times 4 is 32. My remainder is 2. So when I rewrite this as a mixed number, I get 18 and 2 over 4. Can I reduce the fractions part of this answer? Yes, I can. What's the greatest common factor between 2 and 4? The greatest common factor between 2 and 4 is 2. So I'm going to divide both the numerator and the denominator by the greatest common factor, which gives me a final answer of 18 and 1/2. So I'm done. Number 18. How many times will 3 go into 1? 3 won't go into 1. So how many times will 3 go into 10? 3 will go into 10 3 times. 3 times 3 is 9. Subtract those. I get 1. Bring down the 1. How many times will 3 go into 11? 3 will go into 11 3 times. 3 times 3 is 9. Subtract those. I get a remainder of 2. So my answer so far is 33 and 2/3. Now, question. What is the difference between 2, the numerator, and 3, the denominator? Well, the difference between 2 and 3 is 1. So, when the difference between the numerator and the denominator is 1, you're done reducing. Here we go, number 19. Number 19, we've got 114 divided by 5. Will 5 go into 1? Nope, 5 won't go into 1. Will 5 go into 11? Yes, it will. How many times will it go in there? 5 will go into 11 2 times. 2 times 5 is 10. Subtract those. I get 1. Bring down the 4. How many times will 5 go into 14? 5 will go into 14 2 times. 2 times 5 is 10. Subtract those. What's my remainder? My remainder is 4. How do I know that's my remainder? Because it's smaller than the divisor. So my final answer so far is 22, or I should say my answer so far is 22 and 4/5. So what's the greatest common factor between 4 and 5? Well, the greatest common factor between 4 and 5 is 1. So I'm done. Number 20. On number 20, you have 134 divided by 4. How many times will 4 go into 1? 4 won't go into 1. How many times will 4 go into 13? 4 will go into 13 3 times. 3 times 4 is 12. Subtract those. I get 1. Bring down the 4. 4 will go into 14 3 times. 3 times 4 is 12. Subtract those. I get a remainder of 2. So then I get an answer so far of 33 and 2/4. I'm going to bring this over here. So what's the greatest common factor between 2 and 4? Why, the greatest common factor between 2 and 4 is 2. So when I go 33 and 2/4, I divide both the numerator and the denominator by the greatest common factor, which is 2. And my final answer is 33 and 1/2. Okay, on to the story problems. Okay, on number 21, we got Maria had 45 inches of ribbon. She cut the ribbon into 3 equal length pieces. How long was each piece of ribbon? So I'm going to give you guys some tidbits here. Whenever you see the word cut, equal, each, you're going to be doing some dividing. Now, what is the total amount of ribbon that Maria had? Maria had a total of 45 inches of ribbon. She cut the ribbon into 3 equal parts, so we're going to divide by that number. So here we go. 3 will go into, let's see, 45. Now, as you guys get better at this, okay, better at your math and better especially at your multiplication tables, you're going to start making a lot of connections, and as you guys get better at making these connections, you can take some shortcuts. So how many times will 3 go into 45? 3 will go into 45 15 times. Now if you use your calculators and you go 15 times 3, you'll find out that 15 times 3 is in fact 45. And when you subtract those, you get a remainder of 0. So what is our final answer? 3 inches each. Okay, so that's my final answer for number 21. Okay, for number 22, we've got Brian had 58 feet of wire. He cut the wire into 4 equal length pieces. How long was each piece of wire? And write your answer with a simplified fraction. So I'm going to set this problem up on a separate slide and show you guys how to solve it. So from problem number 22, we had 58 feet of wire, and we're going to divide it into 4 equal pieces. So we're going to take 58 divided by 4. So I'm going to set this up with my little house. So 58 divided by 4. 4 will go into 5 one time. 1 times 4 is 4. Subtract those, I get 1. Bring down the 8. 4 will go into 18, 4 equal times. 4 times 4 is 16. Subtract those, I get 2. So my final answer before reducing it is going to be 14 and 2/4. Can I reduce the fraction part of this problem as the answer? Yes, I can. So what's the greatest common factor between 2 and 4? The greatest common factor between 2 and 4 is 2. So I'm going to divide both the numerator and the denominator by 2, which gives me a super final answer of 14 and 1/2 feet. Okay, on to number 23. Okay, number 23, we got Trey walked 61 miles in 3 months. He walked the same number of miles each month. How far did Trey walk, or how far did he walk each month? Write your answer in a simplified fraction. So again, I'm going to do this on another slide, create some more room for myself. So here we go. So here we go on number 23. We're going to take 61 miles, divide that by 3 months, and find out how much he walked each month. So 61 divided by 3. Let's go ahead and set this up with our house. So 61 divided by 3. 3 will go into 6 2 times. 2 times 3 is 6. Subtract those, I get a remainder of 0. Bring down the 1. 3 divided into 1, or how many times will 3 go into 1? It won't. 1 times 3 is, 0 times 3 is 0. Subtract those, I get a remainder of 1. So my answer so far is 20 1/3 miles. Am I done reducing this fraction? Yes, I'm done reducing the fraction because my numerator is 1, so I'm done. So my final answer for number 23 is 20 1/3 miles. Okay, at this time, go ahead and get out a piece of paper and let's get ready to write down the assignment. Adios, muchachos.